Hello everyone, welcome back to my channel. Today we show the equations in graph. And you can see that we start a week with a third one. That's a hard one about graph. That is the largest scalar value in that graph. Okay, the statement gives us a directed graph of n nodes. Is colored. Okay, so we need to do to find a valid path from any node, any path. That's the color value of the path is number of the nodes that are colored the most frequently occurring since a color along the path. So let's take example one. Take a look at example one. You can see we have path from 0 to 4, like 0 to 3, 4, and the color like red here. The red color occurring three times, right? So the answer must be three because we can't find another bus that contain more same color nodes. Okay, and the one of the important we need to focus and note here is this line. Yes, return -1 if the graph contains cycle. That means if the graph contains any cycle, so we must return 0, and if not, we need to find the answers. And when we don't have any cycle inside the graph, we call it a DAG. That's it. Direct DAG graph. Directed a cyclic graph. That's a type graph in which nodes are linked by one way. That's directed. This is one way connections that do not form any cycles. It's a okay. So we call it directed cyclic graph. Something like this. You can see there's no cycle, only direct edge, no cycle. So you may if wherever I see the term DAG, I will refer about topological sort. That's about a short algorithm in the DAG graph. So common orders leaks, but I will not. I will try not to use the term in today's solution. Okay, so the solution today is first we need to check if the graph contains any cycle. If yes, if the graph contains a cycle, so nice one. Else, this is a DAG graph. No cycle, direct cycles direct. Yeah, and right now, first we need to determine if a graph is a cyclic. Let me try to draw some graph here. Something simple like this. Yeah, and you can see there is an edge that form a graph here. That is this, right? So how we can check if there's a cycle? So the ultimate we do is to use a DFF, but that versus an algorithm to do an DFF like from any node, like for example this you do resist, you resist, and suddenly you find an edge that refer back to a node that's in the DFF tree. So that form a cycle, just simply last to the DFF. Mhm. So to DFF resist node to that form a DFF tree. So if there's the edge that's net to a node in DFF tree, okay, that's a cycle. You can find about it's about DFF by a cycle anywhere. Okay, like Chichibuki is the good one. Okay, and now that's the first, and but next, let's try to use some example like this. Let's try to use this. No, no, no. So if the graph is DHG, what we're gonna do, and you can see we we have the state of color. We need to manage the number of color obscurance in the path in any path. So I would like to use dynamic programming here because the DHG so is had no cycle. That's enough. That's it. That's the fully condition to use dynamic programming. Piece repeat you see main like what the color value. That's the color value refer to the angles here. The color values the path has maximum color C. Easy, see? Like you can see that you see the color values. That is the access of any path. That's any path maximum. I mean that's the color C. That color C appear in any path that must maximum. For example, like this one. Like this is like color H, color H, like color H, and this is like color C and color C, like that. Mm. So it's gonna be good if, as you can see, we have two paths from A to E, three paths that is with this and this, and the path that contain the most color of H is this one, right? It's contain two color, three colors, so we can do something like DPA. The color H line is the color like exactly three. So we need to do something like the way the DP array like this. Like among all paths and at starting at the node U, what is the maximum color of C appearance in a path in among that among all the paths starting at A. And so we can do something like have a formula dp that uc is the maximum of all the paths. So must be on the page. Wait a minute. So with base try you what a try here. No, we don't use try with iterations. Trace. Okay, we'll see. Like that. I forgot about the directive. View. Okay. So what's the color here? Color is the on color. So color. Um, on the bus with on color. So the beautiful thing of dynamic programming here is declarative. That means assume we only assume that we have a solution for sub problem. Let me draw some example like this. Last you have a solution for this one, and this one you can combine it to the solution of this. Yeah. So we assume that the maximum of node ending as starting at U and have the color C. Its maximum of the we try to find along on the children on the of that children, so we can determine what's the maximum path, because this at this node we have the maximum path ending starting at this B, right? That's B, and which any color, and we merge with U by get the maximum path among it. And the case when we meet a color that's the same color as node U, that is the big U. I call it the colors of U. This must be like mask on the path from C and have the same colors U plus one, right? Because we asked we found a node that's in node U that contains colors U, so we must plus one, and on the other node we just get the mask path among them. So that's the solution. Let's try to solve it. First, we need to convert it to adjacency matrix. Adjacency metric. Sorry, I forgot the adjacency. Adjacent. Yeah, adjacency metric. Okay. Letter adjacency metric. Really, I even forgot. Try. Oh no, and adjacency metric. Forgot this term and time. So also the dynamic programming is zip value A to Z. What's next? We need to store we need to find the cycle first. U and what got the U U and vector to store in the event tree. A vector to store it in stick. Here, so the event U true for the instance of U. First we need to view the graph first. Edges, adjacent edge 0 plus 1. So we have the graph now. If in the band B, so we found a cycle. If we found a cycle in any children, we will false and not even true. Okay. For all the node, if it's a cycle, so we can start at any node, because as you know, as you can see, for this, like this, we start at this node, we can travel to this, and then we start at this node later, we can travel through C and D and travel to B, and then we stop because we have the answers of B. Yeah, we stop at D because we have the answer of D, so the order is not important here. If TFF has I, so we're going to start the false after minus 1, okay, with our cycle. And now we need to DB. P, we will first we need to the bottom patterns to reside sorry, to reside this side. This is DPI this side. Also, we need to define the bed false, because we didn't have any node in the tree first. And this is the false. After traversing, we mark it as form because we traverse out this node. Okay, now we need to create the diamond one on the color. Try on the color, so we put something like EP use CU because I create here for simple syntax different from using CU. Start of EP CV CU with DBCB. It's just combine the solution just like the knapsack problem. 0 1 knapsack like one is get maximum of on the path. We check on the children of the node U, that's the node V, and get the maximum path that's ending at V. So we append the node U at the end of that ending path, and 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 if that's still current colors is like we need to pass here because we have colors U plus A. So if we have any pass any that V and we append U, and if that the pass contain the color C, so current colors we plus it one, right? Because we found we add the node U with color C to the end of the previous path, so we plus one to all the path that have the node C, the color C. So it's done. It's done here. We need to do the business true. We don't need to. Well, why we use this because we don't want to visit the node that used to be travels to this to visit here. It's contain the answers on the in the DP array, so we can use it instead of calculating again with the memorization. So then, so all we need to do here is to find the answers for color, answers with BBC I run DP color. What? Can't believe there's some silly mistake. Really? Okay. Okay. Equals colors. Resistive as. Oh, why so many silly mistake about syntax? How is got accepted? Okay. Okay. As that is, today we start a week with a challenge. It's a tough one. It's a challenging one about dynamic programming on Rad. We call it DB on tree. We only can use the DB on tree if that's Rad is a cyclic, directly a cyclic. Is that the condition of the that we can use the DP? Because if there's a cycle, we can calculate the final state is in the loop, but we don't know what is the optimal one to use this pin. And that's why in DAG you can use think about dynamic programming on tree first, and this slide, and you can see the state here. We need to manage the color is about A to Z, so that it only consists of 26 colors. You can use DP like DP no with color at the state and try to find the like dynamic programming formulation to form the prompt here, like what I wrote here, and think about some. Mm, because we can think about DP because it's so easy, as, especially in some recursive problem that we can find state, we can form the solution from substate. That is the art of dynamic programming. So bye, have a nice week. Yeah.